under Judea-Pearl, and his research concentrates on graphical models, missing data analysis, longitudinal data. So please join me in welcoming Ilya.
Can you guys hear me okay without a mic in the back? Okay, I guess there is a mic actually. Thank you for inviting me. It's a great honor to be here. So I'm in computer science. I do sort of data adjacent things. And typically people in computer science who do data adjacent things are machine learning people. And I'm not a machine learning person, so I should say that right now. I'm a causal inference person. So this is joint work with my brilliant student Razi Anabi and my brilliant postdoc Daniel Malinsky. Somebody asked me before, like 5 minutes ago, if I was going to do a review of fairness, and I'm not, because it's really a big area now in machine learning and statistics. However, I will plug my friend Shira Mitchell's website. So she maintains a website called Mirror Mirror, Reflections in Quantitative Fairness. You know, like who's the fairest of them all, that kind of thing. So you can Google for it, it's easy to find. And she tries to give a comprehensive review of fairness approaches, both in the machine learning community and the causal inference community. And I think they have an archive kind of survey paper now as well that you can find. So I won't really, I'll just talk about how I think about it. And please, I hope that we'll have a discussion, basically. This is more of a conceptual talk. There is some numbers later. But I won't talk a lot about statistical methods, but more about how I think about fairness, and maybe we could discuss whether that's the right way to think about it. Okay. So people use statistics and machine learning in all sorts of ways these days. Presumably, if you're an insurance company or a bank, you probably use statistical models to make certain kinds of decisions. Like if you want to give somebody a loan, you might worry that they would default on a loan. So they'll probably ask you a lot of questions, and they'll probably have some sort of internal statistical model to predict the default probability or something like that. I got involved in this area because I've read this expose by ProPublica. I think one of the authors actually gave a talk in this room some time ago about that work. And about how people are using kind of predictive algorithms in the criminal justice system for bail and sentencing. And I think that expose made me pretty mad. And so that's how I started thinking about this. And so these algorithms, they're complicated regression or classification methods that people in machine learning did, or possibly policy learning algorithms. And the worry is that algorithms can reinforce human prejudice if used thoughtlessly. There are lots of examples of this, and essentially, one problem that you run into is regressions just map inputs to outputs in some way, and they don't really think very hard about how those inputs and outputs were defined, and they could be defined in various inappropriate ways. So I'll give you an example. I'm from Baltimore City. In Baltimore City, well, it's a city with a lot of problems. If you've ever seen The Wire. Cops preferentially hassle certain kinds of people, in particular young African-American men, with more or less justification. Certainly sometimes they hassle people needlessly, and sometimes they hassle people needlessly in such a way that they end up spending the night in jail. And then that ends up in your criminal record, and then your criminal record might be longer than it would be otherwise for no good reason. And then you might subsequently try to use some sort of model that looks at your criminal record, and then you'd have a problem because essentially it looks, like you might think that somebody with longer criminal record is a danger to society. You shouldn't let them out, or you should take appropriate mitigating steps. But the worry is that what you measure is not measured sort of in a fair way, and this happens all the time. And statistical models, of course, don't. There is no, by default, they don't worry about any of this. They just map inputs to outputs, which is what regressions do. And so you have this other kind of discriminatory bias, or however you like to call it. And it's different from things like confounding bias, which is people in causal inference, which is something people in causal inference think about, or statistical bias, which is what everybody in data analysis thinks about. So a lot of people now are thinking about fairness, both in machine learning and in statistics. There is this large conversation consisting of lots of papers back and forth about how to define and measure discrimination and fairness, and how to make causal or statistical inferences fair. in scare quotes. And of course, as you would imagine, there are as many criteria as there are papers, essentially. Sometimes more criteria than papers. Okay, so I'll talk about prediction problems mostly, but I'll talk a little bit about policy learning at the end. So the setup is you have a set of covariates X, and you have some sort of sensitive variable, like gender or race or sexual orientation or disability status, and an outcome. And the question is, given that we have some data on these variables, we want to make predictions or decisions based on X and S. Might we be discriminatory with respect to S? What would that mean? So I think there are three parts to this. So you have to define something, you have to define some criterion, and then you have to argue for why we should care. And then you should have some method for satisfying this criterion. And so I've been trying to read since I started working on this various fairness papers, primarily out of the machine learning community. And what I find is often this second step, the analytic philosophy step, is missing. They just propose X, and then they say, great, I'm going to now that we've proposed X, I'm going to now give you a fancy method based on something I know about to make X go away. And then here's some plots after we apply this to some data, end of paper. And so I think that's unfortunate. And I'm worried that fairness is one of those things that I really think we should try to get it right and have a kind of, it's related. Real people's lives are being ruined every day. And I think we owe it to them to actually think about this properly. And that isn't to say that there's necessarily a single X. There are probably multiple X's. Fairness is partly about ethical intuitions people have. And people's intuitions conflict. So one politically controversial example is affirmative action. Affirmative action is controversial, I think, because two separate notions of fairness conflict. One is that sort of retributive fairness, and one is proportionality fairness. So there's a strong intuitions people have that fairness is proportionality. In other words, if you get a higher score, you should be rewarded because you got a higher score. But on the other hand, people also have another intuition where, if you've been wrong, you should be, that should be corrected, essentially. So those are both true, and in the case of affirmative action, it conflicts, and so people argue about this. And so this is not unusual. This happens all the time in the political arena. And that's fine, and I think, I feel that our job as analysts working here is to just try to make these arguments as explicit and mathematical as possible in a marketplace of ideas, essentially. And I'm gonna talk about a particular kind of notion of fairness, and we could talk about how useful it is. But I certainly don't claim that it's the only useful thing to think about. So our approach is inspired by causal inference because I'm a causal inference person. So in causal inference, you move from a factual world, which is the world you have the data on, to some counterfactual world where things are more convenient. For example, you're interested in whether smoking is bad for you, and so you can imagine a hypothetical randomized control trial where you randomized a potentially harmful exposure versus not, and then you would never be able to get this past IRB, so you can't actually run this trial, but you could imagine trying to predict this trial under assumptions. So you try to predict this very convenient world where things are randomized to draw some conclusions about effects of the exposure. So similarly, fair inference we think about as a move from an unfair world to a fair world, whatever that means. And so I have this definition in red. I'm gonna talk about it more later. But for now, we think of discrimination with respect to some feature for y as the presence of an effect of the feature on y along certain unfair paths. So I'm going to give an example of what I mean by that. So that's one. So one thing we could argue about is whether that's a good definition. Another thing we could argue about is, given this definition, what do we do? So what we want to do is we want to move the entire problem over to a fair world where the criterion is satisfied, essentially, where there is no discrimination as we defined it. That might not be what everyone wants to do, and so we can talk about that as well. So it's sort of arguing about the definition or arguing about the method. Okay. So let me give you an example of why we define this way. So I'm from Hopkins. At Hopkins, we're in the middle of PhD recruiting season, PhD student recruiting season. We just had our visit day. And in computer science, we don't actually give offers before visit day. Visit day is partly an interview. And the way we do it is we get 500 applications. And then we look through these applications. And based on the strength of those applications, we invite a smaller set of people to an on-campus interview. And all we see is what's in the resume or the CV. Okay. So one thing we see is gender, or we see somebody says that they're male or female on the form, but also you can tell by the name sometimes. You might also see race, or you might not. So we have some legislation such that we cannot discriminate based on certain kinds of characteristics. And the question is, if we're doing this process of reviewing applications and inviting people over, might we be discriminating with respect to these perceived features that we see? So how could we tell if we are? So one intuition people have here is they do this kind of experiment, and I think people have done this before. What they do is, you have a set of resumes, and what you do is you split evaluators into two groups that are hopefully similar, and then you flip a coin, and then you either give the original resume, or you give the same resume, but you switch the name and the recorded gender. And the point is, if all you see is the resume, that's perceived gender. So you could hypothetically change it in that setting. Obviously, if the person's in front of you, you cannot change gender. But if all you see is the resume, the only perceived gender is it's just stuff on the form, essentially. Okay, and so the point is you only change the perceived gender. You change nothing else. You don't change anything substantive about the resume. And then, you decide who to invite in both arms, and then you compare. And then the point is that if you notice an appreciable difference in the two arms, then there is the strong intuition that something went horribly wrong with the process, because all you've changed is the perceived gender and nothing else. So it must be that any appreciable difference is due to that. Okay, so that's the intuition. So our notion of fairness tries to kind of mathematize that intuition in general. Not the only thing you could do, but that's what we decided to do. Okay, so this is a quote from this is a twice removed quote. The original quote is from a legal opinion, but Yuda Pearl quotes this in his book, Causality. It's a judge, I think, and he says, essential question in any employment discrimination case is whether the employer would have taken the same action had the employee been of a different gender, and so on, and everything else had been the same. So the stuff in red is the counterfactual connectives of that sentence. So the sentence is counterfactual, clearly. So this particular judge seems to think that the whole thing rests on evaluating a certain counterfactual, essentially. And that experiment I described in a previous slide is essentially trying to get at that too. It's counterfactually changing just the characteristic, but nothing else. Yeah. So if we agree with this, if we agree with that kind of experiment, and if we agree with this opinion, and I think there are other opinions in the legal literature that are not like this, so it's complicated. But if you agree with this, then essentially this means. I'm sorry?
Can I ask a question?
Yeah.
Well, you just already got rid of, by that statement, affirmative action, right? So from their childhood, from their schooling, there's discrimination. At the moment of that hiring decision, they have worse CVs. So there's no discrimination by your criteria, by that experiment, but no one would say they weren't discriminating in getting there. And this is the problem I've had with other fairness papers. They're trying to be fair from where they are this day to their decision.
Right.
Why would that? I mean, I can see that's necessary, but it
Yeah.
hardly is sufficient for a definition.
Oh, absolutely. So the example. So I gave this example of criminal record. Criminal record is totally spurious in Baltimore for a lot of people because they get hassled, basically.
Right.
And then you might think that what you should keep the same. You should just change the race but keep the criminal record, but that's not true, right?
No, it's really different because if it's spurious, just get rid of it. It's when it's real. If you have some job people with good education will really do it better. But a whole class hasn't had good education. That's all.
Because of structural problems, basically.
Really.
Yeah, I absolutely.
It's like, I mean, if you don't do it throughout the life course, it's gay.
Right.
That's all.
Yeah, absolutely. Yeah. I mean, but you need to make progress. So if you could do it at a single point, you can try to do it once you do it in the, as you say, possibly from the beginning, from birth, essentially. But you'd need something like this anyways. What was another example of this? I think it was tryouts for orchestras, where they put curtains so you can't perceive the gender, and then they still weren't hiring women, and I think it was because they heard high heels. That's what I've heard. So they put carpets, and then the effect went away, basically. Anyways, yeah, I agree. So this is philosophical exercise, and I realized that what should be kept the same is a live question, basically. And I'll get to this later, but basically we take that as input. So we let bioethicists and lawyers argue about that, or the public at large argue about it. So I don't view it as our job to tell people what the fairness criterion is. And I'll give an example where essentially you could have isomorphic examples where something is fair in one example but not in another, depending on exactly what the variables are called. So our job is to say, translate your ethical commitments into math, essentially. Okay. I guess the narrow point I had with this quote is that this is fairness is a causal inference problem or a counterfactual problem, if you buy these kinds of definitions. In particular, gender happens early in your life, at conception, presumably. So much before, temporally before everything else, essentially, that happens to you. And so consequently, perceived gender, so your real gender influences your perceived gender, which influences a decision, but also your gender influences your life, as Jamie says, in all sorts of ways, possibly structurally bad ways. Trying to disentangle these multiple sorts of paths, there's a sub-area of causal inference called mediation analysis that thinks about that, and that's what we're going to use to try to get at this. Okay, so this is causal. I'm going to do a quick causal inference review. If you know what this is, I apologize for boring you. So in causal inference, we're interested in potential outcomes or counterfactuals. For a single person, it's Y is the outcome, A is the treatment or exposure, and you read that as responsive Y of some person under some hypothetical assigned treatment AI. And typically, the target of causal inference is some sort of population counterfactual average, such as the average causal effect, written over there. You could think of the average causal effect as trying to get at the result of a hypothetical randomized controlled trial where you could assign a control group and the active group to different values at random, and then look at the expected outcomes. Try to judge the efficacy of A based on this. In classical causal inference, we assume lack of interference. In other words, if somebody else takes a treatment, that only affects them and not you, which is not always true. In particular, it's not true in social network settings, in infectious disease potentially. The fundamental problem with causal inference is we never observe for every person both the outcomes under both assignments, only under one assignment, the one they actually got. And so that's the fundamental problem of causal inference, and that's what makes causal inference kind of a missing data problem. And the secondary problem is correlation is not causation, meaning that people are assigned treatments in general preferentially. So in particular, if you just collected data on smokers, probably people don't smoke, and based on the flip of a coin, they smoke because their friends smoke or because they come from a certain background or their friends and family and so on. And these things also affect the outcome. And this makes it difficult to disentangle associations into sort of valid causal relationships you want to base decisions on. Okay, so people, the assumptions people in causal inference make to make progress here is this lack of interference assumption, meaning that if you take an aspirin, my headache doesn't get better, essentially. And consistency assumption, which I write like over there under 2, but essentially what it means is that you can think of how variables are determined in a causal system as by means of this stable causal mechanism. And you can think of this mechanism as a computer program. It doesn't care how inputs are set, whether by nature or by experimentation, and they reliably produce the output the same way every time. That's kind of how I think about consistency, but I guess I'm computer science. But these 2 assumptions on their own are typically not enough. You need to make additional assumptions, and these are sort of restrictions on the way the treatment assignment and the counterfactual random variables are related, and they form the causal model. And the goal in causal inference is to express various functions of counterfactuals of interest in terms of the observed data distribution, and then estimate them, hopefully. Sometimes people use graphs to represent causal models. I do that sometimes. I won't describe them formally. I'll just kind of draw pictures, and we'll get to that a little later. Okay, so the standard example that people like to give in sort of healthcare context is this confounding by indication example. You have people in an intensive care unit. They're very sick. Possibly they're crashing. And if they're crashing, people try to keep them alive and give them certain drugs. For example, if their blood pressure gets very, very low, they give them something called a vasopressor to constrict their vessels, make sure that their blood pressure is in a safe range. And so if you look at the observed data gathered in an ICU, you will very often find a positive association between getting a vasopressor and very low blood pressure or possibly death. And that's because of confounding by indication, meaning that the kinds of people who get vasopressors are already crashing, essentially. And so you have to adjust for the fact that people who did get vasopressors are typically different from people who did not. And so you could imagine a model that basically says the only thing that determines whether you get vasopressor or not is your blood pressure, which is measured. So blood pressure here would be C. The drug, whether you got the vasopressor or not, would be A, and then your hypothetical outcome, like death or crashing, I guess, would be Y. And so you could make the assumptions that essentially the decision to give the drug is only determined by blood pressure and nothing else, and the blood pressure is observed. So that's called conditional ignorability. And under these kinds of assumptions, you could actually express the average causal effect given this kind of data as a function of the observed data distribution. It's right over there. This is the famous sort of stratification or adjustment functional. And given this functional, you can estimate it in lots of ways. Here are 3 of them. One of them is what's called the parametric G-formula approach, where you just do a plug-in maximum likelihood estimator for that functional. One of them is the inverse weighted estimator, and one of them is the augmented inverse weighted estimator based on sort of semi-parametric methods. Okay, so that's causal inference. We'll use mediation analysis in addition to this. Mediation seeks to answer the following question: how exactly does A cause Y? And in particular, to what extent is the effect of A and Y direct, and to what extent is the effect of A and Y sort of mediated by some third variable? So I'm starting to use arrows here, but I mean that informally. This arrow just means there is some direct effect of A and Y, and this means there's an effect of A on some third variable, the mediator, and then the mediator in turn influences the outcome. So to define these mediated effects, people do it in a number of ways. The sort of original way is to do nested counterfactuals of this form, and this reads as what would have happened to your outcome had we assigned the treatment to some value, but then simultaneously made the mediator behave as if the treatment was assigned to something else. Okay, so you can think about a counterfactual like that. The problem with counterfactuals like that is that it's difficult to do an experiment for a counterfactual like that. One second. And this creates controversy, although there are various reconceptualizations I'll talk about in a second. Yes?
So I'm wondering how you think about the relationship between identifying average causal effects here in this causal inference framework and your definition of fairness that you started with, right? Because like ideally, the really uncontroversial definition of fairness would be to identify the individual level treatment effect on a single person, right? And then remove that bias from whatever outcome we're interested in. But that's never going to happen, right? So in any event, we can only approximate fairness on average. And I think that seems to have baked in some kind of utilitarian definition of fairness that's concerned with aggregate social welfare, but not necessarily fairness on the individual level, right? So it might be a little bit more controversial in this framework than you started out with, or than it seems at a first glance. How do you think about that?
I agree. I agree that this is utilitarian because you're essentially averaging over populations, and there is some notion of utility. I mean, I'm going to mention utility later on if I have time. That's true. It's also true that individual causal effects are almost never identified. I don't necessarily think that this implies we cannot do individual level things. I think that's open. I think it might be related to people who think about token level causation in law and philosophy and elsewhere. So like, what does it mean for one event to cause another? So there are people working, I mean, I think it's a super hard problem, but I think it might be related. There might be some sort of token level kind of mediation type stuff you can do. I'm not sure. I'm just not willing to just a priori rule it out because I don't know what's possible really. I definitely agree that this is a population level criterion and it's open to all sorts of attacks because of that. Right? First, because it doesn't help an individual person, and second, because you might not like utilitarianism at all, which is a perfectly legitimate position, right? Yes?
But you're still interested in the conditional average treatment effect and subpopulations, right?
I might be. I mean, I'm not going to in this talk, but I could. I'm just literally going to. I mean, I haven't given you the definition yet. It's going to be some average effect. Yeah.
Right. I see where it's going. But the follow-up question would be how small of a group can you make it before the effect stops being identified? Like if you're going for the K, how small of a group can you actually approximate before?
Well, I mean,
this approach would.
So this is related to. I mean, you can condition on things and look at the cohort where some conditioning event is true. This is actually, so I have a paper on, so like whether conditional mediation is sort of understudied. I have a paper recently on how to identify things like that. It's sort of tricky. But I mean, there are things like that you can do, but that's not an individual level causal effect. It's just
no, of course,
it's
yeah,
just effect modification, really.
But it sort of approximates some of the tendencies. Yeah, that's.
Yeah, you can certainly do that. Absolutely, you could do. Yeah, you could do some sort of structural model, perhaps, if you want to think of. Like if you think that there's some, well, I mean, so this is, maybe we should talk offline about it. I mean, yes, there are certainly things you could do to make it not just be an average, absolutely. Yes. Are there any more? Okay, right, so I think we stopped with nested counterfactuals and how they're slightly weird and do not necessarily correspond in general to a well-defined experiment. And so the way people have been talking about having a back and forth about these counterfactuals is they actually think about it as this composite intervention, essentially, where, so the example is smoking. So you smoke, that's bad for you. Why is it bad for you? Because you get nicotine in your system, which is maybe bad for you. And you also get smoke inhalation, which maybe is a risk factor for lung cancer. And so you could imagine in the data, you either smoke or you don't smoke. And so if you don't smoke, you get neither smoke inhalation typically, nor nicotine exposure. And if you do smoke, you get both smoke and nicotine exposure, okay? And you might be interested in a hypothetical situation of what would have happened if we just set one of the components to a value, but not the other. And the reason people like this example is because in this particular example, it's actually possible to conceptualize such an experiment. In particular, you could imagine setting just the nicotine and not the smoke by giving somebody a nicotine patch. And similarly, if you just want to set the smoke but not the nicotine, you could set, you could just have them smoke something but without nicotine in it, like tea leaves or something. so I think so Jamie Robinson, who is in the audience, wrote had a very nice paper on this precise point and how you could essentially define mediation in a way that essentially reduces these kinds of component-wise interventions in a way that avoids having to talk about these nested counterfactuals. And this is kind of how I like to think about them too, if for no other reason than if I want to do an applied kind of analysis of mediation. That's the only way to explain it to anybody.
I have a
Yes.
comment. You've already done this for them. Because what was that randomized trial of perceived gender? I mean, it's exactly this. In the data, 100%, in your observational data, everybody who has gender has perceived gender. So you can't see the difference. But you got away from the observed data and separated them. And that's exactly what that's saying. If you make that gender and perceived gender, you can run a randomized experiment, but not on the data you have.
Right. That's right. And I think the fact that I was able to tell a story means it had to be like this, basically. Essentially. I mean, that's the claim, I guess, you make, you and Thomas, right? Okay, so you could think of these nested counterfactuals in this way. It's just a component level intervention. So you could then, if you're able to intervene on separate components of smoking, you could then conceptualize a direct effect, which basically compares people who don't smoke with people who got the nicotine patch. And that tries to isolate just the effect of the nicotine. And similarly, you could compare smokers to people who got the nicotine patch, and that says, well, you have these two people who both have nicotine exposure, and one set of people has smoke exposure and one doesn't. So in this way, it isolates the effect of each of these components. And if you could see the way it's defined, you can see that they sum by telescoping argument, they sum to the a's. So they kind of form a decomposition of the average causal effect into these two parts. And you could define it kind of the other way with nicotineless smoke, like smoking tea leaves or something. So it'll be a slightly different kind of effect. Okay, and so similarly, so exactly what Jamie said. You can imagine playing the same game with this campus invitation resume screening example we did at Hopkins. You can compare resumes of men and same resumes with names with perceived gender switched to female or vice versa. I'm not going to talk about path-specific effects because I don't have time, but essentially I've talked about direct and indirect effects, and in general, in mediation, you can think about effects along a particular pathway. And similarly to sort of this kind of simpler mediation, there's a way to define a counterfactual for that, and also similarly, there is a way to kind of define a component-wise split of the treatment associated with different paths. And so in general, I won't really talk about much more about this here, but you can conceptualize fairness in a very granular way by trying to decide which paths you want and which paths you don't want. And this is a larger conversation beyond this specific talk, of course. It's kind of a conversation that should involve ethicists and so on. But the point is there's machinery to think about arbitrary pathways, essentially. Might not always be identified, but it's a separate issue. Okay, so discrimination is the presence of effect along the unfair causal pathways. So ignoring Jamie's point for the moment, we could say that the unfairness here is the direct relationship between gender and a decision, which we intuitively think should definitely not be there, whatever else is true. And fairness is a domain-specific issue. So you could imagine, so one example we came up with is hiring. So you want to hire, and you want to hire for a physically demanding profession like the military or firefighting. And of course, these professions have fitness tests. And it is kind of a live political issue right now because it's well known that men and women pass them at different rates. And the question is that okay or not? So you could imagine, well, I'm a firefighter. I have to, axe doors down and carry people out. So I need to have some minimal level of physical fitness to do that job. And so maybe that's okay. However, if you don't do that kind of job and you do that kind of test, like you're an accountant and suddenly there's a fitness test and it's obvious that this is silly and it's just a cover for discrimination. And you might think that's a funny example, but it's actually not all that funny because there are examples of this happening in the South. There were all these tests that you had to get, like literacy tests that were preferentially given to African Americans to suppress the vote. One example I know from Soviet Union, which is where I'm originally from, is the so-called Jewish problems. So you could buy a book of Jewish problems. I'll explain what they are. It's math problems. Before you go to university in the Soviet Union, you had to take a test, an oral test. They would give you problems and you'd have to answer on the board. And if you were Jewish, they didn't want to admit Jews, so they would give you these special problems that had the property that they were really hard to do unless you knew what the answer was. And then it was very easy to see that that was the answer. So it's kind of P and P kind of problem. And then of course, if somebody, so they needed cover. So if somebody would challenge them on this, they say, but look, the solution is so obvious, right? And so this was clearly just given to suppress Jewish enrollment, essentially, at universities. And so you could go on Amazon and find a book of these problems, just to see what they're like. Yes.
So going back to your sensitive group and all that. So you say there's a discrimination, or the hiring practice is unfair to, say, females if there is a direct effect of gender, even if you fix the perception. I'm trying to map this into the definition of fairness.
This is an example. So I think there's a very large argument to be had exactly what is unfair. So it's possibly the entire effect is unfair. We don't know. For the purposes of this example, I'm going to say that I'm going to ignore structural disadvantages that women face in society, and I'm going to say that it's all about the direct link of perceived gender on the campus invitation decision. In general, that's not true, because there's other stuff on the resume that was influenced by the fact that they were women. Maybe they were discouraged from going into STEM. Maybe all sorts of bad things happened, and that would be reflected, right? So then you would have to include those pathways as well. But this is essentially an endless hole. So I'm going to ignore this for now. I'm just going to illustrate this with just a direct effect. That's a simple effect. I don't want, I want the effect to be null, essentially. Because I don't think it is appropriate for a similar looking resume for me to switch the gender and suddenly for there to be an appreciable difference in invitation rates. That seems not okay.
But that depends on how you pick, like, the C, right?
Oh, absolutely.
Okay.
Well, I mean, in this case, C is whatever's on the resume. So there are certain standard things like letters of recommendation and papers and things like that that they wrote. Probably not everything about them, but whatever they felt fit to include to impress.
So whatever the information that the decision maker has, conditioning on that, whether the gender still have this direct effect, is that what you think?
No, I'm not conditioning. I'm going to literally say what would have hypothetically happened had I flipped the perceived gender in these resumes and compared that to just the resumes with the observed perceived gender. That's not conditioning, obviously, for the usual reasons of confounding and so on. Does that help?
I guess is there a formal definition of fairness, or that you're gonna put out for? I guess
it's a class of definitions. The formal definition is an absence of some path-specific effect.
Okay.
Let's say in a mean scale.
Okay.
What path-specific effect is going to be depends on the problem. In this case, for illustration, it's just going to be the natural direct effect that we don't want. Yes?
So you acknowledge that this word fairness is a bit tricky to use here. So there are cases that if you make that effect null, that's actually discrimination. Acknowledge that there are scenarios. So
Yes,
it's
the
one
main specific.
very narrow, specific setup that you're focusing on.
Yes.
So it's not good to use the term fairness or discrimination at all.
I think I'm comfortable saying that in this particular example, if I switch perceived gender and there is appreciable invitation difference, that's discriminatory. And I think like people could basically sue on those grounds, I think, and probably succeed. I'm pretty comfortable saying that.
Yeah, I'm not discussing the legality of the issue. I'm discussing the morality which you alluded to previously. So which you just addressed that if you have two resumes, one is female, one is male, and suppose you're in a country that we know that women are remarkably disadvantaged.
Okay, so Saudi Arabia.
So
let's say.
I won't name any countries, but suppose you have the male resume has 7 papers on it. It's an academic, and the female one has 2 papers.
Okay.
Okay. Suppose let's not even discuss morality. Suppose I'm just assuming like instrumental rationality, and I just want to maximize my profit, performance, and that's I'm so cold-blooded quote-unquote rational agent economically. Okay.
Okay.
So in that sense, if the female resume has 2 papers, the other has 7. Well, yeah, if I still get the female one, it's strange. It's like affirmative action. It's not. But suppose that the female one has 6 papers or 5 papers. If you remove the effect of gender, I think you're discriminating against women, because it's clear that suppose this woman is a single mom and has like 2 children and still like doing a part-time PhD and still managed to publish 5 papers. Even if I'm a cold-blooded, like profit-maximizing person, it's clear that if I give this person support, they will have better performance.
Absolutely.
It's obvious. Okay.
I couldn't agree more.
Exactly. So in this case, which doesn't agree with your setting, so in this case, it's unfair and it's actually discriminatory to make that effect null. That's why I say let's not use the term fairness or discrimination. Let's invent a new term and use that. Because
Okay.
I don't know.
So I have 2 things to say. First, I think you're concentrating on this example. The proposal is you have to draw a picture. So you told me a story. Somebody's a single mom, and there are all these variables about that person.
That's a basic
that you could
affirmative
draw.
action story.
Well, yeah. So you could draw a
cumulative
big graph, encoding that entire story, and then you say, well, let's think about this story as ethicists and think what would we be happy with. What paths are bad, what paths are not. Maybe we should make dispensations because somebody had a lot of structural disadvantages in their life. And you could tell a similar story. In this case, I didn't for simplicity because I'm giving a talk and there are only 3 variables in this picture rather than 300 as there would be if we actually did it with somebody's life from beginning to their university admission, right? And then we would have something much more complicated potentially, and you would say that's what we should get it. But again, my point is not to dictate what fair is. My point is to say, given that you tell me a story, and you put it as this causal model, this picture, then we have ways of formally trying to come to a consensus on what exactly, like what pathways we want and what pathways we don't want. I'm not saying it's an easy conversation, it's a hard conversation, but I think it's progress that we're able to sit down and talk mathematics about it rather than shouting at each other, right? That's all. And I think, as to whether we should be using the word fairness, the example, I think in the example...
It's agnosticism that you're
Sorry?
trying to... It's algorithmic agnosticism, it's not fairness.
I wouldn't say it's agnosticism. It's well...
Words matter.
Yeah, I agree that words matter. I think that... No, I guess I disagree, but I mean, we could have an offline thing about it. I mean, philosophers have been talking about fairness for a long time, despite the fact that they can't agree on anything, essentially. So I think there's definite, no, but I mean, people, in analytic philosophy, they do examples, right? So, and they argue about examples, and there are some examples where there's like intuitive consensus on what's fair or not. So there's definitely something there, but it's very hard to nail down exactly. And so your response might be, we shouldn't use that word, but I guess that community disagrees. They use that word all the time, despite not having a consensus, and I think that's fine. So I think the specific example with the gender swapping, I think it is one of these cases where it's intuitively unfair, basically, I think, in the setup that I gave. You could give another setup that's more complicated where it wouldn't be, and indeed that's the way the analytic philosophy game works. They modify the example until you get the opposite conclusion. We could just do this forever. Yes?
I'm totally with him about the word, because everybody's writing papers called fairness. This is like people used to write papers called, this causes this, they had no counterfactual thing, they had no assumptions, and we said, stop that. Fairness is used in so many ways, has so many political connotations that you need, if we want to formalize something, you better make the distinction so that everybody's not using fairness. I mean, there are thousands of computer scientists writing about fairness. You say they're not writing about fairness. Why don't you change it?
I'm not saying they're not writing about fairness. I'm saying fairness is complicated and people can disagree on what's fair. And you could have conflicting intuitions about the same problem, but that are both rooted in fairness. So what are we to do? That's just how it is.
No, but I mean, this whole issue about, are you talking about what the individual decision maker at point T has to do when there's a historical background, I think that's always that led to inequality of how well they could actually do the job. I think that's always there. People don't always make that distinction. You're trying to make that distinction, but I think we need words for that distinction because people confuse. And that's all. I mean, it doesn't. I just, you know.
Well, what word do you recommend we use?
Well, my word, Schwäbisch.
Okay.
You will run out of time.
Okay. Well, no. I mean,
Yeah,
this is kind of how I
slide
did.
11.
Maybe call it counterfactual fairness or something, because you sort of mixing it.
There are people who do counterfactual. Yeah, so it's called counterfactual fairness is a key word in this literature.
Okay,
Yeah,
all right.
but some of it is not this. Some of it is other stuff, basically. Okay, so what do we do? So we want to predict. So we're doing predictions. So we're predicting the outcome given some features, and these features include something sensitive like race or gender. Something that occurs, sort of pre-treatment features, and mediators, so things that occur after that sensitive feature. So we'll consider all causal paths from S to the sensitive feature S to the outcome. We'll mark some of them as unfair. So that process probably will have a lot of shouting, which is intended. I don't think it's my job to say what's unfair, and I think it depends on the story and the picture that you draw. Then we assume that, so we get some path-specific effect. It may be identified. We hope that it is. If it's not, then we have to think about what to do about that. Identified just means that it's a function of the data we actually have. And then we just check if it's null or not. And if it's not null, we think that there is a problem. And so I try to kind of build this intuition with that simple example where paying attention directly to perceived gender is bad. Okay, and then we want to find some fair world. P star, some distribution P star, where essentially it's close to the world that we observe, that we have data on, but there is no path-specific effect. So the criterion is satisfied, and we can think of various notions of closeness. I think we used KL divergence here because it's sort of like you try to use the data as well as possible while satisfying this hard constraint that the PSC is not there. Okay. And how we would so I don't actually know how to compute P star, so we approximate. So we don't do as well as actually learning P star. We learn something hopefully not too different from it. And the way you can do that is you could have some sort of likelihood function and some sort of estimator of the identified PSC, and then you just do a constrained optimization problem where essentially you use the estimator as the proxy for the effect. And you want to find parameter values of the likelihood that sort of do as good a job as possible while satisfying this constraint. And the constraint you're going to get, of course, will depend on the models that you use in this estimator. So that's our approach. So that's not actually going to get you P star. In particular, what you'll end up doing is you'll end up only constraining the models that the estimator G uses, but it's not clear that that will give you P star. Potentially, you might have to constrain all parts of the likelihood, and I frankly don't know how to do that. So one area here is how do we actually have better ways of finding P star essentially.
Can I make a comment?
Yeah.
You've already defined quite well the counterfactual world you're interested in. It's the world where they had no idea on the resume what it was doing, okay? Which we sort of see through that randomized trial.
Okay.
So we know a counterfactual world. We know there is a counterfactual world where we could have hidden the gender on resume. So it seems to me that's what we're trying to estimate, to come up with some ad hoc statistical criteria rather than asking a substantive question, what would the world have looked like had we done that?
Okay, so you could have two problems. You could have a problem with the approximation, or you could have a problem with P star itself, the way I define it. Which is
problem with P star.
You have a problem with P star. So you don't think P star is a good definition. So you think it should be something else.
What you see in the counterfactual world.
So can you describe, do you have an explicit definition of it or implicit? I guess I don't know what your best star would be.
What you'd get when you did the experiment that we talked about, you erased.
So what happens if you withdraw the gender information?
If you're
That
removing
world.
gender.
Yeah.
So I think that. So I disagree with you, Jamie. I think that won't work.
Okay.
So I'll give you an example of why it won't work.
Okay.
So So I'm going to talk about Northpoint, which is that company that built these Bayes, recidivism prediction models.
Okay.
So they don't actually use race at all. And in fact, I think no model I know. So maybe I'm misunderstanding you again.
No, you aren't. It seems you're going towards her previous argument, but go ahead.
Point being that removing race doesn't fix the problem. So in Baltimore, let's say I don't use race, but I use zip code. So Baltimore is super segregated. So if I use zip code, I basically use race.
But that's what we've been saying about
Yeah.
from your childhood.
Yeah.
You're black. You got a lousy zip code where there's problems.
So there's
You're
a
now
structural-
coming to ours. What we were criticizing, the problem with the local decision maker. Because the local decision maker, maybe that is a good decision. That's all the data he has. You want to add other things that have to do with systematic discrimination in the past that you, the decision maker, can't do anything about. You're going to choose people who don't do the job as good. You're going to do now arguing for affirmative action, which is not what you argued for before. This logical.
I don't think I'm arguing for. I mean, you could argue for affirmative action in a similar way, but I don't think that's what I'm doing. I think all I'm saying is that removing. I guess the way I'm thinking about the zip code issue, zip code is a proxy, right? So in other words, there's a causal pathway that isn't good, essentially. So just killing something upstream doesn't necessarily fix the problem. Yes, maybe I missed it. Okay.
Well, I think that it sounds like what people are arguing about is this: we don't have a way of figuring out what is good except in these like local domains that you're talking about. But if you leave it up, if you leave hiring decisions up to people that don't have or that only have certain kinds of information and they're used to and comfortable with making decisions based on that information, it doesn't. I don't know if it matters to them if it's a proxy or not. And so, can you leave this fair world decision up to individuals in local domains? Can you prescribe a method instead to determine not just whether or not something is fair, but also how we can figure out what is fair in the first place? That's the analytic philosophy movement that you're trying to make, and it seems like that's kind of like
I don't think
that's where the formalism seems to be.
I
missing.
don't think it's a statistician's job to figure that out.
Okay.
I actually get this question a lot, and I think importantly, I don't think it's our job. So I think of myself as a data person. I don't think of myself as an ethicist. So as soon as you get into these situations where, if it's an accounting firm, it's okay to do the test. It's not okay to do the test, but if you're a firefighter department, then it is okay to do the test. Essentially, statistically, it's an indistinguishable problem, but there's a different story, and you do different things there. So what am I to do about that? I mean,
Isn't
this
it
is an endless
given
thing,
your
right?
categories in the first place, though? I mean,
Sorry?
it's indistinguishable given your categories, right? But if you prescribed a different way of getting the categories in the first place, if you broke it down rather than by using pre-existing categories, but instead by breaking those categories apart and using the elements of those categories, for example, I don't know. I hear what you're saying that you're not acting as an
I don't
ethicist.
think
I don't know. If
I
you
can't
agree with that
invent. I
position
don't
in
think.
general for
I don't think there is a black box that will invent ethics for you. I think ethics comes from humans, and I think it's the analyst's job to try to formalize it. But whenever I give a version of this talk, I actually get this question: why can't you just have a black box that learns what the pathways, what unfair pathways should be? And I just don't see how you could ever do that.
I wasn't talking about a black box, but
Okay, sorry. Yes.
I was saying you should make it explicit. This is our deontological version. This is our utilitarian version. This is our communitarian version, right? That's what I was talking
So I suppose
about.
this is utilitarian.
So you've made your ethical decisions already, and that's the problem. I just like front load them. That's all.
So this is utilitarian fairness, not fairness. Oh,
You
sorry,
could-
no, I take it back. It's not even utilitarian fairness, because by my example, it's utilitarian to actually get the woman. So it's nothing, actually.
Okay.
It's something that you have invented and you call it fairness. As long as you acknowledge that, we're good. But you withdraw, you say, I'm not an ethicist, I'm just doing math, but then you make philosophical statements in your talk. That's not consistent. That's, I think, where the problem
I think the only philosophical statement I guess I endorse here is the gold standard is just what humans think about examples. I don't know how else to do ethics. Maybe people can teach me. Right?
Ilya, you told me an example about, where they lived. You said it was different than the other example, and to me, it's exactly the same. I'm going to take your role.
Okay.
All I'm going to say is, well, I'm going to view that as a pathway. One started at birth. I can't do anything about it. Well, I can. I'm going to not let you see on the resume both your gender and where you live. How many and it may logically, if there's enough discrimination playing your game, I may not show you anything on the resume.
Okay.
Flip a coin.
So here's where I think we are. So I propose to do something. You propose to do something which is a little different from what I propose. So the question is, how do we decide what proposal to use? I argue that the way we should decide is we should try to construct an example and ask people and see which one they like better. I mean, how else would you sort this out, basically?
Which people are going to ask?
Well,
I think that's a real problem.
so I
because,
mean,
like,
I agree. I mean, I
the
think
utilitarian principles are like all up in this university and all other universities, right? And so it seems very obvious that this is how people think. But if you go talk to like working class white, white or black Hispanic people in southern LA, Los Angeles, it looks very different. Like what we should do is we should do what's best for our family, not necessarily what's best for maximizing my own utility, right? Or maximizing any other utility, right? And just saying like ethics look very differently depending on whom you talk to. And so you can take the average, right? But that's just a utilitarian principle then in that.
Yes.
On that, so.
Okay, so anyway, so I think I don't have any. So Jamie, I don't really have any defense in this for this criteria other than we should just ask people and see what they like better, because I don't, it's not, again, that's the gold standard. It's not me like telling people what fairness should be. It's we work out 3 to 5 examples and then see what people would go with. The interesting question is the huge chunk of literature doesn't even do that, where they essentially propose X and then they have a fancy method for making X go away. And so arguably that it's unclear what that is. Okay. So this is our proposal. Our proposal is there is a number that we want to be 0 essentially. And if it's not 0, we make it 0. That's our constraint. And then we maximize the likelihood with that number 0. Okay. So the other, so this is so there is this question that, I mean, we have an answer for this question, but this is probably a general question for all fairness proposals, especially that move somewhere other than the observed data. And that proposal is what we do with new instances, or the issue. So new instances come from P, the observed data distribution. If you're doing out-of-sample prediction, which is sort of a typical machine learning setting, you have some training data and then you fit your regression on it, and then you have new instances that hopefully come from the same distribution as your training set, and you want to make decisions there. So what we did is we moved to another distribution defined in some way called P star, and then Jamie had some proposal for a distribution that's also different from mine, P tilde. So it's not the same distribution anymore. So the question is it a problem that new instances are not from either of these distributions? So I argue that it is a problem. I argue that we want to be in a world where whatever the fairness criterion is that we like should be satisfied. And I think it's sort of related to this whole structural injustice and cycle of injustice business. So I think, and I think to move to that world, potentially you have to ignore some information. And so there are various ways of doing it. So I'm going to describe one way, this is perhaps conservative way. But the issue, I think, is general. And so I think I'm hoping we'll have some discussion on this as well. So what we assumed is we just assumed that P and P star share some marginal. I think what we assume in the specific proposal that we assumed, essentially we have some estimator, and that estimator uses a part of the likelihood, and everything else we think is shared. And so what that means is that we only use the part of the new instance to predict that is actually shared between the two worlds. And whatever isn't shared, rather than using the instances, the values of the instance that we observe, what we do is we throw them away and then we average out over what we think they should have been had this person come from P star, essentially. So I'm deliberately throwing information away. So maybe that's bad. But I think that something like this would have to be done, essentially, if you want to move the entire problem over to satisfy your fairness criterion, even if your problem involves some sort of online setting where you have new instances essentially coming from the wrong distribution. So you have to do something about this. And if you don't do something about this, what's going to end up happening, your criteria, if you look at the distribution of you like making predictions or doing decisions with these instances that you use unaltered, I think you will end up having this distribution not satisfying your criterion again. So you're kind of back to square one. Okay. Or there's no particular reason to suspect that any criterion you choose, if you don't essentially correct new instances somehow, that it will be satisfied at all. Okay. Any questions on this? I was actually expecting a lot more pushback on this than there ended up being. Maybe it might be all the pushback came before. Yeah.
Maybe this is still on the last thing, but I'm just thinking about. So you've described like the existence of path-specific effects as being the fair, so we somehow we all fight and agree about what the fair and unfair paths are. But it seems like based on some of these people are saying, people might also care about the signs of those paths and interactions between things. And so we might think that certain directions are fair or unfair based on past experience. Right? We might assume that it's okay to correct for historical discrimination, but not so that direction of bias is okay because it's serving some sort of long-term goal and fair. But things that are direction of the bias would be unfair. So that would be saying something like certain path-specific, the direction of certain path-specific effects are fair, and other ones are not fair. And I just wonder if you can you, like, if you're trying to zero this out, but if you did run into a situation where there was like, basically some sort of like self-correcting positive discrimination, like this was a self-correct for past discrimination, which doesn't, empirically I don't think doesn't happen very often, but could be a thing. Could you handle that from like in this framework?
Well, if you accept the criteria, which you may not, and then you're now interested in positive path-specific effect, it sounds like you're interested in something like affirmative action then, which may be a fine thing to be interested in. Right, you can imagine, I'm not interested in the fair, in scare quotes, world. I'm interested in the world where I'm correcting for something in a way that...
But can you selectively zero out? More like I'm saying is...
The point is, I don't have to zero out. I could set it to anything you want. And then, the argument really is an ethical argument, like what value of this specific thing do we want?
Yeah.
And as far as interactions and so on, yeah, you could talk about all of that. So there are various, there's a structural nested version for direct effects. So you could talk about a complicated model with interactions in there and think about that model and like what coefficients in that model you want. If you buy that, yes. I don't know if that. Yeah. But okay, but that's the last thing. But there's nothing about this. Okay.
15 minutes.
Okay.
11 slides.
Well, that's good. I'm not even halfway done according to slide count. So the specific, the expose that got me interested in this was something ProPublica did, and they, so there was this company called NorthPoint, and they wrote about this company and this tool that they developed, which is some sort of proprietary regression model that used a bunch of features of people and developed a so-called compass risk score that was used for, I think, bail and sentencing. And people, this particular, and the model is proprietary, but they did publish some of the data, and it received sort of a lot of attention in this fairness community. And there are these examples you could find where it really looks like this model is doing something slightly sketchy, where there are two people, an African American person and a Caucasian person, and it sort of looks like the Caucasian person got a low score, even though if you look at objectively at their characteristics there, they seem much worse. So this is more like, you shouldn't take this analysis very seriously. This is an illustration of how you would do something like this. the specific data that we had is recidivism as an outcome. We had race. I think we restricted our attention to just Caucasian and African American cohort, but I think it's actually the largest subset. It's about 5,000 people. We had some demographic information. Races, we're going to assume it was randomized. It's necessarily a good assumption. And we had a measure of criminal record. For the purposes of illustration, we're going to assume that we don't want the direct effect of race on the outcome, although I kind of got done talking about how, in reality, parts of the criminal record might be spurious, and you might want to include them. It's not necessarily simple to see from that data which parts of the criminal record it might be. So we just think, did you? No. Okay. So we included, essentially we made, for purposes of illustration, the assumption that essentially the path mediated by criminal record is fine, the direct path is not fine. The specific estimator we used for the direct effect is this one. This is what's called a mixed estimator, which uses the outcome regression model and the propensity score for S. And because S was randomized, P of S given X is just the proportion, so it's correctly specified. And we use the constraint MCMC essentially to fit the essentially do a constraint MLE for the outcome regression. I'm not going to talk too much about exactly how we do it. We use the random forest essentially in rejection sampling. And we found the direct effect. It's actually I didn't have the significant digits here, but it actually is away from 1. And if we predict recidivism with just the observed data, with the partial compass data that we were given, we get something like 67.8% accuracy. If we constrain the model, the Y model, and I think we didn't actually set it to null, which would be 1, but we had some sort of tolerance. And this was only done for reasons of running time. Essentially, rejection was very slow. And accuracy went down. And this is not surprising because you're not doing the MLE. If the model is correctly specified, you cannot, of course, beat the MLE. And here, in addition, you're summing out over certain information that in sort of with held out data, and because you're summing it out, you're essentially not using information as well as possible, so you're not predicting as well. And so the question is that bad? So there are all these papers on negative results in fairness problems where essentially you can simultaneously use the data as well as possible and satisfy fairness criteria. And the question is, what should we do about that, those negative results? And so my argument is that chasing optimality in an unfair world is not interesting, because we should be interested in whatever the world is where whatever our notion of fairness is satisfied. And if that is, if you seem to be doing less well, then that's just what it is. Yes?
So in this example, what are the variables in X? Demographics? Education?
Yeah, it wasn't very many. It was things like age and like zip code and things like that, actually. So like some sort of measure of location. I think education level and some other things.
But if it's zip code, you're assuming the association between race and zip code.
Right. Sorry. I didn't think it was
Those
zip
kind
code.
of
Sorry.
correlations are fair.
Yeah, sorry, I don't think it was zip code. I think it was some sort of location, and I don't think, from what we saw, it was significantly associated with S. Yeah.
You are taking at face value. The one thing you haven't changed is what the outcome is. Why? But why you told us at the beginning was unfair, because cops are busting, arresting, black kids for being black.
So
So
that's
that
yeah.
biases the outcome, right?
I would say it biases M, not the outcome. I think outcome is defined, like recidivism is defined as something serious you did. Now, maybe it's not always a kosher, like arrest or
Okay,
something like
let
that.
me do another one.
Okay.
And this is again, which values you're going to trade off. Let's say this is stealing from someone, maybe even violent. But if you send people back into a neighborhood, if you have to go back into a neighborhood where there are no jobs except for selling drugs, then of course they're going to have more racism. Of course they're going to hurt more people, and you get in the same moral quandaries about why.
Well, why is what I constrain, by the way. I constrain the Y model. I don't constrain anything. So the game that I'm playing that you may not agree with, so that constrains whatever my estimator uses. The estimator that I use is over there. So that estimator uses Y and S. S is a fraction, and I didn't touch it actually. So it's just Y.
I think, but maybe maybe I'm misinterpreting Jamie's point, but I think the argument is that if you let people vote on which of the paths they will want in there, like a member of the community who's worried about crime, they're going to vote for none of the paths are unfair. Like the hiring person is not going to care. Like the person who's hiring may not care about fairness and discrimination, right? Well, there's a favoring of the people that the person being discriminated against here, but that's not necessary. And like that may not be a widespread agreement in the community about that as fairness. And so I don't know how you would ever resolve the issue where two people, like society disagrees about what is fair.
Well, I don't think it's my job to resolve it. I think it's society's job. I think it's my job to say, we'll try it your way and then we'll try it the other way. And then we compare and then we fight it out in the public square, basically.
This is the problem. You're using the word fair. The public, when you say that, thinks you're saying fair. No, you're not saying fair. You're saying this is the criteria algorithm. You decide what's fair, but you're doing fairness. I mean, the words being, even by you, are being used in strange ways. Because you're now calling this particular method fair, but society should decide which things are fair.
So the thing
which
is
one thing back.
But Jamie, you're putting me in an impossible situation because it's certainly.
I think it's an impossible problem. Right. And I think the more people acknowledge it, the more there'll be political understanding that this isn't something to be solved by an individual decision maker. And there won't be all these academics saying, I've solved this problem. Because they have.
Well, I'm certainly not saying this. And I think
using the word fair.
I'm trying to take great pains to say that I need input from people who just argue about ethics in the public square, because I don't think it's my job to determine ethics for people. And I think there are people in the community who do think it is their job, and I think it's very bad. Yes?
But as a scientist, do you agree that you're responsible for the way you present your research to the public?
Yes.
Do you agree that? Okay. So please, let's all be careful about the terms that we use when we're presenting our research results to people.
Yes, I agree.
And the effects that our words can have.
Yeah, I think so. Yeah, I mean, there is this worry that, data scientists are like technopriests. They're going to. Yeah, I absolutely agree with that. I think this is an incorrect attitude. But I think if anyways, I think this is an offline discussion about how you should think about this. So, like there are some methods that if you agree on certain things, this is what you should do. So there are names for those things that we could agree on. We could talk offline about what that should be. I do think like fairness like picks out certain things and not others, like because people agree on this. Sorry, go ahead.
So I wanted to ask, is it possible for some of the concerns around trajectories of unfairness, so like in S being incorporated in M through unfair pathways in the past, is it possible to alleviate some of those concerns by thinking about this as like a longitudinal problem with certain paths that you're trying to break in the whole chain, rather than just at the point of the decision maker, whatever the decision maker is?
Yeah, that's right. If you want to think about paths and you draw a big picture, then there's this whole machinery for thinking about mediation and longitudinal settings that, yeah, we could talk about. Absolutely.
So I'm trying to think about how to incorporate what you're doing here into the more common debate that exists with this data, which is the sort of impossibility theorem, right? Which is that you can't have a well-calibrated model that is also producing equal false positive and false negative rates across racial groups.
Yeah.
So that's the argument that people debate that this data is used for. So, I mean, being an impossibility theorem, it means that this can't solve it. And so I'm trying to think, like, how does it speak to that, those two conceptions of fairness? Or is it doing something else?
So I have a different criterion. My criterion is rooted in these experiments we do. And I think that I kind of moderate. So I used to think it has to be something like this, but I've now come to realize that, of course, it's very complicated. And you could, but I think all I ask, if you like equalized odds, which is a perfectly fine thing, like you have to tell me a story about why it might be something I should care about. Because, you know, causal inference has this long history of torpedoing things, essentially, where you think something seems intuitive, but actually you forgot about some confounding thing, and so there are these counterexamples to it.
Yeah.
So I think that these kinds of associative criteria, they're kind of vulnerable to that, especially for things that are not like race, which you can think of them sort of loosely as randomized, but these downstream, like you're released from jail, so you've paid your debt to society, so we can discriminate based on you being in jail. But actually, you have all this confounding for that treatment, and so associative criteria will fail basically.
Right. Yeah. I guess what I was pointing out is that, sorry, that you've pointed out the fairness efficiency trade-off in the terms of the accuracy, but like as just highlighting, there might be trade-offs between different conceptions of fairness, and by imposing these constraints, you might actually be making the types of fairness that other people care about as they define it worse, and so that's something I don't know.
Yeah, absolutely, you may. I mean, I haven't looked at it because I didn't care about it, at least for the purposes of this paper. But yes, absolutely. I mean, you could imagine trying to satisfy multiple sets of constraints. That's fine. It's going to tank your accuracy even more, presumably. Sorry.
It's not a minor remark. The way you use the word story also, just to clarify, stories are not necessarily contrived scenarios pertaining to some special case. Some stories capture the majority, the default scenario in some settings. So
when I say story, I basically mean some causal model, like possibly a big one.
The story I gave was not some minor, like special case of, oh, this might happen. In some settings, this is the majority of the cases. But wherever you have positive feedback, that's the case.
I should say, like, contrived, I don't view kind of, like you say, there are these stories that are like edge cases. I actually don't think that those stories are bad. I mean, that's the way analytic philosophers make progress. Is they, you know, they try to nail down a definition. And they do thought experiments. And I don't think there's anything wrong. So, like, to the extent that you thought that was kind of slurring it, I'm not. I think it's perfectly fine.
Your example, I think, is actually, from the kind of things we're talking, is an easy one because, okay, they don't get to see gender. You were still worried about that they aren't taking into account all these other things. But if they were rational, they would have done it, and now they'd use all their covariates. They would have taken their past training history, and they would definitely say, that person, I'm going to take that person rationally rather than the other. They can find that out just by doing regression. So I don't think that, they just have a bad classifier given their data. That's the way an ML person would say.
If they have all the other covariates.
Yeah.
If they do have all the other covariates. Yes.
Right. Okay. I'm actually going to stop. I had some more stuff, but I think I'm actually happy that we had I was kind of expecting a fight, and the fight I got, and that's fine. I'm going to skip a bunch of stuff.
Again, the way you use the words, it's not a fight, it's a cooperative
way
for
it's
a better outcome of our research community.
Cooperative
That's what
representation.
you're doing here. It's not a fight.
So thank you all for coming, but we can take the conversation offline. Thank you.
There are definitely
other things that, yeah, like, but I think that